Let's talk about Kafka distilled today. Kafka was named after Franz Kafka. It is supposed to be a system optimized for writing. It was first released in January 2011. The goals of Kafka were three: scale. So it should scale for lot of producers, lot of consumers, lot of messages. And the second goal was speed. So the time it takes for message to be consumed after it is produced should be very less. Third, the messages should not disappear, so they should be present even when there are nodes that fail. So it should be fault tolerant. Let's see how Kafka achieved that. So there are five key things that Kafka did that made it, uh, what it is today. So first is because Kafka gets immutable small amounts of data. Each of those events or messages are very small pieces of data, and they are immutable. Kafka uses append only file writes. So, and we know that sequential data access, both for reading and writing, it is much faster than random access, at least in magnetic disks, right? The second key thing that Kafka does is Kafka's one of the primary job is to take data in and then transfer it out. So it always reads from network, writes to disk, and then reads from disk and transfers out to the network. The faster it can do these things, the more resources it can conserve and hence scale. So what Kafka uses is zero copy principle, where the number of buffers that you use before the data is sent out from the disk to the network is minimized. It uses send file, uh, system call from OS to transfer file to directly socket buffer. For it to send a file from the disk to the socket buffer, it needs to keep the message in the same format as it should be sent. Then it can directly say that from this file at this offset, take this message of this many bytes and send it to the network. Third, Kafka has to support large number of consumers, so it saves lot of time by not tracking consumers. So it doesn't, unlike previous queues, which used to track consumers, so they would remember, how many consumers have read the message, and once all consumers have read, they would delete the message. uh, all that you would take time and resources of the server. Kafka doesn't do that. It expects clients to know their own offsets in a topic. They also, the records don't disappear once they are read. So it gives an additional feature of long term storage of records, and different policies can govern when those records are cleaned. So that allows files to be generally written in append only mode without a lot of cleaning up happening at the same time. Next, it Kafka has to support large number of producers. So for it, it uses distributed architecture. It has multiple nodes or brokers, and each of these brokers may own one or more partitions, and partitions is something that allows the parallel writes on the same topic. We'll talk a little bit about partition again, uh, but yeah, and fault tolerance is achieved by replication between these nodes. Finally, for speed, Kafka processes each record individually and does not batch, so that gives a very low latency from message production to consumption. So here is an example of how Kafka actually works. So there can be many producers. They produce messages. They would generally produce messages on a topic, but each message has a key. That key decides which partition the message goes to. Within a partition, the messages are put in append only mode, so the order is maintained. Order is only guaranteed within partition. Across partitions, there is no order, and that also gives the scale that Kafka needs. So if you partition your key properly, you may have a lot of partitions, and hence you can have a lot of parallel writes happening at the same time. From consumers point of view, all the consumers uh, have to know the offset from which they want to read, and they would generally say that, start giving me messages from this offset, and that's also a sequential read. So that also takes the burden away from Kafka on managing consumers, and they're having some scale limits on consumers. So now consumers can go to any scale, because Kafka doesn't even have to know how many consumers are there. Let's talk about the zero copy principle. So the key idea is that there is a message on the disk, and that has to be transferred to the network. How would one do in traditional applications? There would be a process which would say that, which would read the file and then make uh, a pass the message to the network. So for it to read the file, it will ask the OS will go and read from the disk, put it in an OS buffer, and that buffer then gets copied into the processor's memory, in the user space, and then process, a thread in the process would pass that message into the socket. And there are a lot of context switches that happen behind between kernel space to user space, and in the process between threads, as the contents of files are read piece by piece, and all this involves CPU. So this is a very costly process. What Kafka does, it uses send file API of the OS, which bypasses some of these processes and directly moves the data from the disk to the socket buffer and into the socket. So that speeds up uh, the sending of data outside. Thank you. Thanks for listening. Hope you enjoyed this.